All right, so today we're going to be looking at arc and angle measures. Most specifically, what happens when you have intersecting chords, intersecting secants, and intersecting tangents. So yesterday we had intersecting tangents outside the circle. We're going to look at some other different types of intersecting tangents other than what you saw yesterday as well. So look at this theorem right here. If two secants or chords intersect inside of a circle, and you can see that happening right here. These are two secants, aren't they? And they're intersecting inside the circle right there. Then the measure of the angle formed is equal to half of the sum of the measures of the intercepted arcs. So the measure of angle 1, we're going to find out right here. Aren't these vertical angles?
Yeah.
Okay, so we're going to take the intercepted arcs, which is AD and BC. We're going to add them together, and we're going to take half. So the measure of angle 1 is equal to half the measure of arc AD plus the measure of arc BC. So then what would the measure of angle 2 be? Because here's angle 2 with its vertical angle, right? So half of
AB
and
BC.
okay, so we have to add those together. So 1/2 the measure of its intercepted arcs, which are AB plus DC. So when you have two intersecting lines inside the circle, you have two intersected arcs. All right? So let's go ahead and apply those on a few of the problems down here. So you have two different situations that could occur. You've got a situation like question 1, 2, and 3, and then questions 4, 5, and 6 are a little different. So let's look at, we'll just look at number 1. So we're going to do number 1. So if I'm going to find AED, isn't AED right here?
Yeah.
Okay. What are the intercepted arcs of AED? AD and BC. Dustin's not the only one that's going to answer me today, is he? Right? So, so the measure of angle AED is equal to half the measure of arc AD plus the measure of arc BC. I'm going to squeeze that in there if it kills me. So we have equals 1/2 times, what's the measure of arc AD? What is it? 45 degrees, plus the measure of arc BC, which is 109. So take your handy dandy calculators, add 45 and 109. What do you get? 154 divided by 2 is 77. So the measure of angle AED is equal to 77 degrees. That's not so bad, right? Okay. So question 2 and question 3, they're all the same. With the exception of, let's look at question 3. What do they want?
The measure of
YWX. They want this angle here, don't they?
Yeah.
They want this angle here. Did they give you its intercepted arcs? No. But you can do this a couple of ways. Let's just go ahead and do this. If I know these two arcs, won't I know what these two arcs are going to add up to?
Yeah.
How?
Because they're vertical angles, right?
Well, that doesn't mean their arcs are equal. Look at their arcs are visually different, right?
Yeah.
Lily?
Yeah.
Almost.
Supplementary angle.
No, not supplementary. Almost 360 though, right? Because the whole circle is 360, isn't it? Couldn't I add these two together and subtract them from 360? Wouldn't that give me what's left over for those two?
Yeah.
Right? So I can find those two. Or you could find, which maybe is what you're thinking of, you could find this angle right here, couldn't you?
What?
You could find this angle right here.
Yeah.
Couldn't you? Isn't it supplementary to this one?
Well, yeah. Aren't those two angles supplementary?
Right.
Yeah. That's
Right.
what I was saying.
Right. And I think that's what Lily was saying too.
Yeah.
So there's two different ways that you could solve that. Do you want me to go through and solve it with you? Yes?
If you
Okay.
want to, yeah.
So which way would you like to do it? Do you want to find this supplementary angle first and then subtract it from 180 to get your final answer?
Yeah.
Okay. Okay, we can do that. So then let's find the measure of angle YWV.
21.5.
Oh, stop it. So it's equal to 1/2 times 43 plus 81. So your 43 and 81 is 124 divided by 2.
21.5.
No, I don't know what calculator you're using.
What are we doing? Wait.
It should be 62 degrees.
Oh wait, I was doing something different. I was doing
Clearly.
1/2 of 43.
No.
Yeah.
Oh, well, okay, you could do that, but that's harder. Yeah.
That's
All right, so
harder.
then, well, yeah, because you have to take
Oh, no.
1/2 of 43 and 1/2 of 81. You'd have to distribute it, and those are ugly, right?
Yeah, I guess.
Okay, so then the measure of angle YWX is equal to 180 minus the 62 degrees. What do you get? What do you get? What? 118 degrees. Right? So that one's a little different. If they don't give you the intercepted arcs, you can find the other vertical angles and then just subtract your answer from 180. Okay? All right, so then let's look at 6. So in the case of number 6, they're giving you this angle here. Doesn't that allow you to find all of these angles here?
Yeah.
Because if this is 79, what's this one?
79.
79. And then how would we find this one?
It'd be 101.
Why?
Because you subtract 79 from 180.
Yep, and so that's 101, right? So look to see what they want to find. They want to find the measure of arc QT. Well, arc QT belongs to these vertical angles here. So shouldn't we do what Dustin said and subtract the 79 from 180 and get our 101 here?
Yeah.
And then what I don't know, I'm going to let be x. So we're still going to use our formula, but we're going to plug in the values that we know. So I'm going to start out with my general formula, the measure, and just pick any one of the two vertical angles. The measure of angle RUS is equal to 1/2 the measure of arc QT plus the measure of arc RS. So let's plug in what we know. We know the angle measure is 101 is equal to 1/2 times arc QT we're letting be x plus the other arc we know is 95. So our x is trapped in jail, if you will.
Is that a Q?
That's a Q right there.
Yeah, right.
That's
there.
a Q.
Okay.
So isn't our x stuck in jail? We've had these problems before. How do I get rid of a 1/2 in front of parentheses?
Multiply by 2.
Does everybody get that? Dustin, you're no longer allowed to talk today. Thank you for sharing. I know you're wide awake, but the rest of them need to think. So to get rid of 1/2, we're going to multiply by its reciprocal, right? Its reciprocal is 2 over 1, and we're going to do that to both sides, so we have to multiply the 101 by 2. Not over 1 because it's not a fraction. So what's 101 times 2? 202, I heard that, is equal to, the 2's here cancel. And aren't you left with just an x plus 95?
Yeah, you are.
So how are you going to solve for x? Yeah, so 202 minus 195. So what does x equal? 107. Does that look to make sense? And that's in degrees. Okay, where are you confused here?
Like the whole 2 times 1.
Were you okay with this equation here?
I saw it all, yeah.
Okay, just answer my question. Were you okay with this equation here to begin with?
Although, yeah.
Okay, so you understood how we came up with that. If I try to distribute the 1/2 into the parentheses, I end up with 1/2 x, and how easy is it to take 1/2 of 95? Not so easy, right? So I would prefer to get rid of that 1/2. Can I get rid of the 1/2 by multiplying by its reciprocal? Well, the reciprocal of 1/2 is 2 over 1. What I do to one side, I must do unto the other side. Okay? Right? For algebra, what I do to one side of the equation, I have to do to the other side. So that's why I'm multiplying both sides by 2 to balance the equation. Don't I get 202 here? Doesn't the 2 cancel out here and the 1 cancel out here, and it just leaves me with an x plus 95? That's why I did that. And now, isn't the math easy? Just subtract 95 from both sides. Don't you get 107 for x? That's all we did. Now, does that answer the question? Is this QT? Arc QT?
Yeah, it does
Yeah.
answer the question.
So this is equal to the measure of arc QT. Right?
That was good, Miss Spring.
Thank you.
I'm proud to call you the math teacher.
I'm happy you're my student, Dustin.
Oh, that's so nice of you.
All right, so then let's...
Student and I'll stay Clark.
Well, we're not going to talk about other students.
Yeah.
Austin's totally different. I love
Oh,
Austin.
right.
See, hear that, Austin? I love you. Okay.
Dang it. I forgot you were recording.
All right, so let's look at another type of intersection. So on this particular circle, what type of line is this? Or piece of a line?
A secant.
Okay, remember, you're not allowed to talk today.
Oh, was secant right?
Yes. Isn't this intersecting the circle twice? Right? So it's a secant. What kind of a line is this? Everybody but Dustin. A tangent. So when a secant and a tangent intersect, you get this nice little angle that looks like this. And you can see all of these different pictures are all showing secants intersecting with a tangent. So again, remember this theme of 1/2. When the two secants intersected inside the circle, we took 1/2 of the sum of the intercepted arcs. But notice that there's only one arc that's intercepted when this happens. Here, there's only one arc here. There's only one arc here, right? There's only one little bitty arc there. So when a secant and tangent intersect, it's going to be an intersection on the circle because of the tangent. You're only going to have one arc intersect, but we still, if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is equal to half the measure of its intercepted arc. That's how you can remember some of these. Okay? So the measure of angle 1 is equal to 1/2 the measure of, what's the intercepted arc of angle 1?
BA.
You are not allowed to talk.
Why not?
You're done, because they won't talk when you talk.
Yeah, but it goes
No,
so
I can't help it. I want them to think. Isn't this the intercepted arc, BA? So that is what you're taking half of, the measure of arc BA. So then look at angle 2. There's another side to this as well. So angle 2, what's its intercepted arc? BCA. You have to name it with 3 letters because it's a major arc. So we're going to take 1/2 the measure of arc BCA. All right, so you have to pay attention to which one they want you to find. So on number 7, they want us to find the measure of angle DEG. So from D to E to G, that's this arc right here, or that's that angle. So we're going to go ahead and use that formula. So kind of the same thing. Is it any different up here if an angle is half of the intercepted arc? Is that any different than an intercepted or an inscribed angle? Is that any different than an inscribed angle? Wasn't the inscribed angle also half of its intercepted arc? Right? So why can't I just look at this and go, okay, visually that's bigger, and we have to go to something smaller? Can't I just take half of 308 and get that angle? I mean, you could look at it this way. The measure of the angle itself is 308. I think this is harder. Is equal to half. Oh, I just did that backwards. Oops, hang on. I'm going to get it yet. Oh, no. Okay. Whew. All right, so I really don't want to do that. Why is this wrong?
I don't know.
Where did I put the 308? I put it where the angle goes, right?
Oh, yeah.
So I want the measure of the angle, which is DEG, is equal to half of 308. I'm just going to try to prove to you that it's easier to think in terms of our inscribed angles that we did a couple of days ago. So what's half of 308? Yeah, 154. Couldn't we have just taken the measure of 308 and taken half of it to get to the smaller angle? Just like we did with inscribed angles, right? All right, well, look at number 8. Number 8 wants...
already done?
That was it. Those are easy. Number 8 is angle DBC. So from D to B to C, we want this angle here. But they gave you this arc here. I want that arc. How do I find this arc? George. Okay, we could do that. He says take 192, divide it by 2, and you get that angle. Subtract that from 180, you get that one. You can do that. Yeah. I probably would never do it that way, but you could do it that way. I'd rather find the arc and then take half the arc, but both are just the same amount of math, aren't they? So how do I find this arc? 360 minus the 192, right? Minus. All right, so 360 minus the 192.
168.
Oh, jeepers. 168 degrees. And then I want to go from bigger to smaller, so take half of that. What's half of that? 84. So the measure of this is 84 degrees. So I want you to do number 9 on your own.
You're really going to do this to us right now?
Yep, do number 9 on your own. Okay, what'd you get for an answer? 58 degrees is correct. There's a bunch of ways you could have done it. I chose to find the measure of the angle here first, so I subtracted the 151 from 180 and got the measure of the angle, and then I doubled it. Because you're going from the angle to something bigger, you have to double it. All right, so are there any questions on that?
Nope.
Okay, well, flip the page, flip it, flip it. Then we have 3 different types of exterior intersections. We can have an exterior intersection with 2 secants, a secant and a tangent, or 2 tangents. An exterior intersection means that the 2 lines meet or intersect outside the circle. Same theory applies. We're still taking half of the intercepted arc, but this time when the intersection occurs outside the circle versus inside the circle, we are going to subtract the intercepted arcs. And you have to subtract the smaller arc from the larger arc. So you do have to pay attention to that. So, for instance, the measure of angle A here, which is the bigger arc? CE. So it's going to be half of the measure of arc CE minus the measure of arc BD. And then on the secant and the tangent, the measure of angle A is going to be 1/2. Which is the larger arc? Is it BC or is it BD? BD is the larger arc. So it's going to be half of the measure of arc BD. That's not the right ones. Over there. Those two piles. Minus the measure of arc CD. And then the third one here, we're going to take half. Which is bigger, this one or this one? BDC. Now this is an interesting one because when you have two tangents intersect, essentially you're going to subtract the entire circle of arcs, right? Because all of this is a major arc and this is the minor arc that's left over. So we're going to take the measure of the major arc, so the measure of BDC, and subtract the measure of arc BC. So isn't there a general theme? Anytime two lines intersect, you're going to take half of the intercepted arcs. If the intersection is inside the circle, you add the intercepted arcs and take half. If the intersection is outside the circle, you subtract the intercepted arcs and take half. If the intersection occurs on the circle, you take just half of the one intercepted arc. You okay with that? Okay.
You said that kind of really fast.
But what's my theme?
I mean, you're just kind of saying what's like on the paper.
Exactly.
You're saying it so fast.
But what's the theme? You take half of what?
Half of the like measured
Of the intercepted arcs, right? When do you add the arcs together?
when
You either have an intersection that's inside the circle, outside the circle, or on the circle.
you add when they're inside.
So you add when they're inside. Okay, Dustin doesn't talk. What do you do when they're outside? You subtract. What do you do when they're on? Just take half. Just take half, right? Because there's only one arc. So you're always taking half. That's my point. All right, here we go. All right, so look at number 10. Number 10, we have two secants, right? So we're just going to take, to find the measure of the angle, and the angle we're looking for is KLM. So that's this angle right out here, so it's outside the circle. We are going to take 1/2. With an intersection occurring outside the circle, we are going to subtract the intercepted arcs. Haven't they kindly given us both intercepted arcs? I don't have to find them. I expect to see that work written out. I don't expect to see it all done in your calculator. Some of you are not getting credit on your homework for that. So 140 minus 66 is 74. Divided by 2, what did we get? What did we get? 37 degrees. That's not so hard, right? Well, it gets a little harder when you look at like number 11. That's it. It gets a little harder when you look at 11 though. I want to find the measure of this angle right here. Do I have both intercepted arcs? No. But I have 1, 2 out of the 3 arcs. Can't I find the intercepted arc? This one right here? How do I find that one?
62 plus 88 and subtract it from 360.
Okay, so we're going to take 360 and subtract 88 and subtract 62. What do we get?
Shoot, I actually did 66.
Well, we get 210. So we have to find that before we can even solve the problem. Then, to find the measure of the angle, now we're going to take half of the sum or difference of the intercepted arcs. We're outside the circle. Difference. Outside, we subtract. So I'm going to take the bigger 210 and subtract the smaller, which is 62. So 210 minus 62 is 148 divided by 2.
74.
74 degrees. Not so bad, right?
Not so bad at all.
Okay. Look at... You okay? Everybody okay?
I'm good.
All right, just want to make sure I wasn't moving ahead too quickly. All right, so look at number 12. Number 12 is where you get two tangents intersecting. They kind of look funny. Do I have all of the arcs? I have this arc is with 313. Do I have this arc here? So subtract that from 360. All right, so let's do 360 minus 313. What do we get? What do we get?
49. Or 47.
47. So this is 47 degrees. Squeeze that in there. So now to find my angle, I'm going to take half of the difference of the two arcs. So 313 minus 47 is 266 divided by 2 is what? 133 degrees. All right, so then you have a couple of problems where they actually give you the angle and one of the arcs. You have no other way to find the other arc. So look at this question here, 14. If I'm finding the measure of arc SW, which is this arc right here, it's one of the intercepted arcs to this outside angle. But we have the angle, and we have one of the arcs. What I don't know, I let equal what?
X.
X. So I'm going to let that be X. Go ahead and set up your equation. So I'm going to actually use my general equation. So the measure, and I'm just going to call this the measure of angle U, just to save space, rather than TUV. That's only one angle at U, is equal to half. Which arc is bigger? SW. So the measure of SW minus the measure of arc TV. We're going to plug in what we know. So I know that my angle is 40 degrees. So I'm replacing the measure of angle U with 40 degrees equals 1/2 times our SW we're letting be X minus our TV is 75. Doesn't this look familiar? Doesn't this look like the intercepted arcs where we knew the angle but not one of the arcs? Right? So how am I going to Tristan, how am I going to get rid of that 1/2?
You times it by 2
on both sides, right. Look at you. So we're going to get rid of the 1/2 by multiplying by the reciprocal. So 40 times 2.
80.
Yep, 80 equals, these cancel, and I get X minus 75. You need to add 75 to both sides. What does X equal? 155 degrees. Okay? So those are all the same. Any questions on that? No. All right, so go to the second I gave you. Arcs, angles, and algebra. So now we have some expressions. These are a little bit more difficult. And you've got them mixed up. You've got two secants intersecting inside the circle mixed up with a secant and a tangent intersecting on the circle mixed up with all of your different intersecting tangents outside the circle. So let's just start with question 1. Let's just start there and look to see what we're going to do. So remember, it's always half of the intercepted arc. And with the algebra, you set up the full general equation, then plug in what you know. So if we're solving for X, and this is the angle that they've given me, then these are the two intercepted arcs, aren't they? So I'm going to be using those two angles. So the measure of my angle, so I'll just call it, I don't know, the measure of my angle is equal to 1/2. Am I going to add my arcs or subtract them when we intersect inside the circle? Add them. So it's arc plus arc, because nothing's really labeled on there, is there? So plug in what you know. We know our angle is 3x plus 23. Let me do that better. I can do it better. 3x plus 23 is equal to 1/2 times 75 plus 55. So what's 75 plus 55? Yeah, so we get 130, and then we're going to take half of that, which we can. If we couldn't take half of that, what if that had come up to be 133? What would you do? If this number comes up to be odd and you can't divide it by 2, you're going to multiply both sides by 2 over 1 to make it easier on yourselves. So if that happens, that's what you can do. But we end up with 3x plus 23 equals 65. Isn't that easy to solve from there? Subtract 23. You get 3x is equal to 42. And divide by 3. What do you get? 14. Does that answer the question? Yeah. They could have asked you to find the measure of the angle, plug it back in.
So
whenever the numbers that you both have to add are like odd.
You multiply by that reciprocal to both sides, which implies on the left side you'd have to multiply both terms by 2. Okay? All right, so then let's look at 3. Look at number 3. Shh, look at number 3. So this time we have a secant and tangent. How many intercepted arcs are there? 1. So don't we just take the measure of the angle? Measure of the angle is equal to half of the intercepted arc. Agreed? Because there's only one arc. We know the measure of the angle is 6x minus 38 equals 1/2 times 140. What's half of 140?
Probably 70.
Yep. So that equals 70. And, you know, theoretically you could have taken half of this, which is 70, and just set it equal to that, which is what we just did. And so then add 78, what do you get?
148.
And divide by 6. What do you get?
24 point with a bunch of 6's after.
So you get 148, so 6 doesn't go in there evenly. 148 goes in there, 24.66666, so we're going to do 24.6 repeating.
Wait, what did you get? It's 38.
Oh, it's because I can't read my handwriting. You guys are awesome. Okay.
I'm so confused. Did I do it wrong?
No, it's because I can't read my handwriting. Isn't this a 38?
Yeah.
Good catch, George. All right, George, thanks for keeping us on track. So plus 38, that's what happens when I can't read my handwriting. How about 108?
Yeah.
So 6x is equal to 108. Now divide by 6. Oh, that's much better. X is equal to 18. Hallelujah. All right, so then let's move to number 5. Let's. All right, so number 5 would be 2 tangents. All right, do we add or subtract the arcs? Okay, so the measure of the angle is equal to 1/2 times arc minus arc, right? Big minus small. So I know my angle is 7x minus 1 is equal to 1/2 times, my bigger arc is 161. My smaller arc is 65. Let's see what 161 minus 65 is. 96, which is easily divisible by 2. So we get 7x minus 1 is equal to 48. Add 1, we get 7x is equal to 49, and divide by 7. We get 7. So not so bad, right? Mm-hmm. Okay, so the question is, how do I know whether I subtract or whether I add or just take half? So anytime we have an angle outside, where the two lines intersect outside the circle, you're going to subtract your arcs. If the intersection occurs on the circle, you only have one intercepted arc, you just take half. If, like on this one up here, the intersection occurs in the circle, you're going to add those. So in is addition, outside is subtraction, on is just half of what you see. Okay, then let's go ahead, bless you. Let's go ahead and flip to the next page.
Is this page our lowest?
No.
We're not having any homework?
No, we are having homework. Don't get so excited. Shh. So let's skip all the way down to question 13. I like 13. All the way down to 13. So let's label what they gave us. They gave us arc QTS is 16x plus 23. Then they gave us that arc QS is 7x plus 15, right? And then they gave us the angle right here is 5x minus 3. We have to find the measure of arc QTS. So does that mean we have to find x?
Yeah.
So step 1, the measure of the angle, which is r, is, yes?
Couldn't we just add QTS
Okay. No.
and QS
No.
and then subtract this from
No.
here's like 4260?
No.
Oh.
Oh. Okay, well you could.
Yeah.
Yes, you
Wouldn't
could.
that be easier?
No. Not necessarily. I mean, Dustin's saying in this particular case, you could add these two up and set them equal to 360 to find x. Yeah. And then you could plug it in there. Yeah, I mean, you could.
Yeah, it seems like it'd be easier.
Okay, if you want to do that, we could do that.
Yeah.
We could.
This way, like,
But it's not going to work like in in this one up here. It's not going to work that way.
Well, yeah, because it doesn't, our
All right, then fine. We'll do 12.
No.
Yes. We'll do 12 then. I'm running out of time. Stop. So then arc DA is 23x minus 14. And then arc DB is 9x minus 4. And then DCB right here is 5x plus 11. So we're going to take the measure of our angle. It will be equal to 1/2 arc minus arc. Right? And this one you cannot add these two and subtract them from 360 because you're missing that arc there, right? True? Okay, so we're going to put in what we know. We know 5x plus 11 is exactly equal to 1/2 times, the bigger arc is 23x minus 14. But we have to subtract, so I'm going to put brackets here. We have to subtract this arc, 9x minus 4. And the reason why I did that was, don't we have to subtract all of this? So you have to add the opposite, plus a negative and a plus.
wait, is that 27?
23. 23. All right, so then you end up with 5x plus 11 equals 1/2 times. What is 23 minus 9x? 14x. What is a negative 14 and a positive 4? Negative 10. Can I distribute and take half of those? Yeah, that distributes nicely, doesn't it? It does. If it didn't, you'd multiply both sides by 2. So 5x plus 11 is equal to 7x minus 5. Collect your x's. So if I subtract 5x, I have 11 equals 2x minus 5. Add 5. Don't I get 16 equals 2x?
Yeah.
And then I get x is equal to 8. Does that answer the question? No. So this is step 1. Step 2. Okay, so then you're going to plug back in to find dA is equal to 9x minus 4. You're going to plug in the 8 that you just found. And so you get 9 times 8 is 72, minus 4 is 68 degrees.